Hello, in this video we're going to be going through number systems, and the first one we're just going to talk about is the decimal number system. Now for the decimal number system, you should all have learned this when you were younger, and we learned that if these were placeholders here, so if I had let's just say this many numbers here, so I'm just going to put a border around it so we can take a look at that. So we learned that in the first place where we had numbers, there were units that were available there, so it would be a singular value that was placed there. And we learned as you went one up, let me just center this stuff, as you went one up it became your tens placeholder, then your hundreds placeholder, then your thousands, and so forth. So then and you would increase as you went up. Now you can explain this in two different ways. One of the ways is that if you had 0 as your smallest number that you could put into this placeholder, 9 could be your biggest placeholder. So if you had 9 units or 9 single items, the next biggest is 10. And then from there, if you had 9 tens and 9 units, you had 99, which means your next biggest placeholder would be hundreds. So then we would have 0 minimum there, 9 maximum there. So if we had 9 hundreds, 9 tens, and 9 units, we had 999. So our next biggest value was 1,000. This can also be explained or taken using 10 to the power of 0 for my first placeholder. Now anything to the power of 0 is 1. So my first placeholder is 1. But the reason why it's 10 to the power of 0 is because there's 10 different possibilities. If you go 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you'll see it's 10 different possibilities based on 0 being the first possibility, and so forth. So 10 possibilities to the power of 0. The next placeholder, 10 to the power 1, which is 10, 10 to the power 2, which is 100, and then 10 to the power 3, which is 1,000, and then 10 to the power 4. So you've got your different placeholders as you continue up the numbering system, and this is the decimal numbering system that we use. Now, computers don't have the luxury of 10 different options. If you have a CD, it either reflects light or it doesn't reflect light. So it's either it reflects or it doesn't reflect. If you're in the CPU, it's either electric going through the circuitry or it's not electric going through the circuitry. If you're looking at a hard disk drive, it's either magnetic or it's not magnetic. Solid state drives either conduct electricity or don't conduct electricity through the parts that they sort of work with. Now, when you go from there, so my solid state drive knowledge is not 100% sure how those work exactly. I don't know, it's got to do with logic gates and things like that, I'm not sure. Anyway, the main thing that we're talking about here is from decimal numbering system. Now, we've got what's called a binary number system. Now, binary number system is what the computer uses. And the computer will also have placeholders. So if we've got this placeholder, I'm just going to copy this down from above. I'm going to place it down here. Now, okay, so now, the first placeholder can have a smallest value of 0 and the biggest value it can have is 1. Now our first placeholder represents 1s. Also, there's two different possibilities. There's a 0 or there's a 1. So there's two different possibilities. So if this is 2 to the power 0. Same thing as we did up here. This biggest possibility here is 1. So the next value is 2, which could also be 2 to the power 1. That was not the 2, that's in inverted commas. Okay, so 2 to the power 1. Which now, if you had the smallest value being 0 there, and you had 1. So if I had 1, 2, and 1, 1, that means I've got 3 in the decimal numbering system. So my next biggest is 4, which is 2 to the power 2 to the power 2. 2 to the power 2. Now, here 0 is the smallest, 1 is the biggest. So if I have 1, 4, 1, 2, and 1, 1, that's 4 plus 2 plus 1, which is 7. So my next biggest value is 8, which is 2 to the power 3. Now, as we proceed through that, let's quickly make this formatted a bit prettier. As we proceed through that, you'll see that it will increase up to 16, 32, 64, 128. Now that there is 8 bits, meaning that it's 1 byte. So 1 byte of information can store. So now if I have this 0, 1, so each of these placeholders represent, so like here we have units, tens, hundreds, 1000s, 10,000s, 100,000s, and so forth. In binary we have 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128s, and the next biggest would obviously be 256. So what you'll notice is that if I had 1, 1, 1, 1, that would represent the number 31, and the next biggest value will be 32. So if I have 8 bits, the largest number I can store is 255. So there's 0 to 255 is the number that can be stored in 8 bits. So if you ever have looked into coloring systems, you'll notice there that they talk about 8-bit color being 256 different colors. So 0 being black and 255 would be the later option. Okay, so I hope this can kind of make sense to you on as far as the number systems and how computer number systems work with regards to units, 2s, 4s, 8s, and placeholders. Very much the same as 1s, 10s, hundreds, thousands. Now to continue from there, we can look at converting between these numbers. So if I had, and it would be represented with a I can't remember what the word for it is. When I format text, you get a subscript, that's it. So subscript, so for example, if I had 201, you could, I wouldn't know how to do it in Excel, but if you had subscript 10, so meaning that it's 201 with the subscript of 10, I'm going to try to do this as best as I can. So if it's 201, the subscript of 10, meaning this is a decimal numbering system. Whereas if I had 101, the subscript of 2, so if I had a 2 here, so let me just format paint this across and take a look at what we've got there, then that means this is in binary. So it would be a 2 below to show that this is in binary, and a 10 below to show that it is in decimal numbering system. So it's just to indicate what kind of numbering system this is. So if I wanted to convert this 201 into a binary numbering system, what I would do is I would take a look at, I would start off with the number 201, and I would look at my 8 bits here, and I'll take a look at, I'll start on the far left, and I'll say, does 128 fit into 201? And the answer is yes. So it means I would have 128. So if I now subtracted 128 from there, so if I took 201 minus 128, which would give me 73, then I would have 73 left. So I've got 128 and I've got 73 left. I then go to my next placeholder, which is 64. And does 64 fit into 73? Yes, it does. So I would have 164, and I would subtract that from here. So 164, which would then okay, so then I've got 9 left over. So now when I do that, now does 32 go into 9? No, it cannot. So it would be 0, 32's in there. 16 can't go into 9 either. 8 can. So there would be 18. So I would subtract 8 from there. So now I would copy that calculation across again. So now I've got 1 value point left. So there's 1 value left. So no 4's can go into that, no 2's can go on that, and 1 can go on that. And now if I do that, you'll see there that there is 0 left over. So now I have completed, so my typing's gone pear-shaped, but I have completed the conversion. So 1201 in decimal is the equivalent of, let's write it up here, 11001001 in, let's copy this across, and that is in binary notation. So decimal notation is 201. In binary, the exact same value is 11001001. So that is the binary equivalent of the decimal value 201. Now if I had to convert this one, 101, which is in binary, and now I needed to convert it into decimal, you'll see there that I can go and I can take a look, and I'm going to delete this quickly, because we now have the value 000000101. So I have 1 4 and 1 1, so I take 4 and I take 1 and I sum those together, which is equal to 5. So the equivalence of this is the value 5. I'm going to do, and this would be to the power 10, or to the 210. This is the decimal numbering system. Okay, so I'm going to do one more example with you guys in this video, and then I would ask you to proceed through some of your own examples. I will put the exercise up on here, or we can add a couple more values to it later as well. Or you'll be handed out, or a link to it will be provided below. And please subscribe. I'm trying to look for subscribers if you're watching this on YouTube. Okay, I've lost my train of thought. Oh yes. So we're now going to be doing couple more examples. So let's go and do, let's take 105 on the binary system. That's to the power 10. So this is in decimal. So for now I'm just going to say decimal. And in our binary system, let's take 1100101. Okay, so this is in binary. So let's try these two examples. So let's start with 105. Okay, there are 0 128s that go into 105. So if I've got 105 here, there's 0 128s going into there. But 64 can go into there, so I have 164. So I subtract 64 from there, which would give me equals to that plus that. So that's 41 that I've got left. And 32 can fit into 41. So there is 132 that fits in there, so I subtract 32 from there. So now if I add those up, then I have 9 left. Okay, so that's easy enough. I have 0 16s can fit into there, 1 8 can fit into 9, and if we minus 8 from 9, we have 1 left. So then it would go 0 4's confident into there, 2's confident into there, 1 can fit into there. So then that would leave me on 0. So the equivalent, 30 minus 1, which would give me 0. So the equivalent of 105 decimal is 0110101 in binary. Okay. Now, next step is we need to look at converting 11001101. So we have 1 0 0 0 1 1. A common mistake made is some people will often write it the wrong way around. In other words, they start the 1 on this side and they start the 128 that side. You don't write the biggest number is on the left. Your left. The biggest number is on the left. And the smallest number is on the right. Same as the way your decimal binary system works. So just remember, smallest value is on the right, biggest value is towards the left. So just remember that. Okay, so we're now drawing this in. We have 128, because we have 128, so we know we have that in there. We have a 64. We don't have a 32. We don't have a 16. We do have an 8. We do have a 4. We don't have a 2. We do have a 1. So now I'll just add those all up. So I could either just, because I'm doing this in Excel, it's easier, I just can sum this whole row up. If not, and if you're doing this in your head, I would take 128 plus 64, which is 192, 192 plus 8, 300, 305, 205, oh, sorry, 190, 205. Okay, so this one is then 205 in decimal. So we've learned how to do the two numbering systems here. And yeah, as I said, thank you for watching. I'm hoping you work through your own exercise well. I'll have a link below, or it will be handed out to you depending on how this is being distributed to you. But yeah, goodbye.